Taking niacin, also known as nicotinic acid, would be about 50 times more efficient than taking the amino acid tryptofan to boost NAD, because only about 2% of tryptofan is converted into niacin. Also, tryptofan didn't work to improve mitochondrial or muscle function in physically compromised older adults, even when combined with niacin or nicotinamide. And side effects of taking tryptofan include belching and gas, blurred vision, diarrhea, dizziness, drowsiness, dry mouth, headache, heartburn, and potentially a life-threatening condition known as eosinophilia myalgia syndrome, or EMS. There was an epidemic of EMS tied to tryptofan supplements from a single supplier back in 1989 that led to their removal from the market for about 15 years. Some sort of contaminant was suspected, but the cause remains a mystery. To this day, tryptofan supplements continue to be tainted with impurities, with at least one case of EMS reported decades after the initial epidemic. A case of EMS tied to a bizarre weight loss diet involving hundreds of cups of cashews, a rich source of tryptofan, suggests the syndrome can be caused by excess tryptofan directly. If anything, tryptofan restriction may be beneficial. Nearly 50 years ago, it was demonstrated that restricting dietary tryptofan reduced cancer rates and increased the lifespans of rats and subsequently mice. Vegetarians and vegans both appear to have significantly lower intakes of tryptofan, but only in vegans does this translate to lower tryptofan blood levels, though presumably not if they were to take tryptofan supplements. What about taking NAD directly? This isn't practical because of instability and poor bioavailability. NAD is vulnerable to heat, pH, light, oxygen, requiring dark desiccant storage at ideally 20 degrees below freezing. NAD can be given intravenously, a practice started in the 1950s as an underground treatment for alcoholism, but when taken orally, NAD may be broken down in the alkaline environment of the small intestine, and NADH, the so-called reduced form of NAD, is broken down in the acidic conditions of the stomach. In organic chemistry, the gain of a hydrogen atom is said to quote-unquote reduce the molecule, so NADH is the reduced form of NAD. Enteric forms of NAD could potentially survive the digestive tract, but with the exception of neurons, NAD can't cross into mammalian cells. This is why NAD precursor supplements like NMN and NR were developed. Also, there's evidently unpublished data showing that straight NAD can cause severe hyperglycemia in mice. Has it been tested in people? NAD-boosting supplements had been found to improve the learning and memory of rodent models of Alzheimer's disease in the lab. In 1995, case reports of apparent benefit of NADH for Alzheimer's disease were published. By the next year, an open-label pilot study was published, suggesting it had a protective effect, but without a placebo control group, the only conclusion that could be drawn was to study it further, especially since a similar study with the same dose over approximately the same period found no evidence of any cognitive effects. There have been 2 randomized, double-blind, placebo-controlled trials of NAD precursors for Alzheimer's. One found no benefit for memory, attention, or clinician ratings of dementia severity, but did maybe find less of a drop in one dementia rating scale after 6 months of 10 mg a day of NADH. The other, a 6-month study of nicotinamide, failed to find any clinical effects. What about trying NMNH and NRH, the reduced forms of NMN and NR? They both appear to boost NAD higher than their non-reduced counterparts. In vitro, NMNH can raise NAD levels up to 10 times higher than NMN, and NRH, also known as dihydronicotinamide riboside, is up to about 50 times more potent than NR. There are concerns about stability of NRH outside the body, since it's sensitive to oxygen and moisture, but within the body, NRH may be more stable, not rapidly devolving into nicotinamide like NR does, at least in mouse blood. However, unlike NR, NRH does not appear to be able to significantly increase levels in mouse muscles. NRH is said to have a spectacular potency for increasing NAD levels, perhaps the most potent precursor discovered to date. This may not necessarily be a good thing. The extreme boost afforded by NRH had detrimental consequences in human liver cells in vitro, resulting from an excessive accumulation of free radicals. In addition to oxidation, NRH was also found to promote inflammation. Pro-inflammatory effects were noted for NRH on human immune cells in vitro, but not for NMN, NAM, or NR. Because it appears that NMNH is converted to NRH to enter cells, these potentially deleterious effects may be shared by NMNH as well, though this is yet to be tested.